in elementary that you learn this, but this, I looked it up. This is the first time you actually learn this. So, for a real number a, the absolute value is written as 2 vertical lines with the a in between, and it's a positive number. So what does it actually mean? So 2 vertical bars around a number or an expression are used to represent the absolute value of a number. So because absolute value actually tells you the distance from 0, the absolute value of 5, if I count the distance, it's always 5 units. If I look at -5 from 0, it's always 5 units. So a lot of people just remember absolute value is it's always positive, but really what we're measuring is the distance from 0. So of course the absolute value of 0 is just 0 because it's at 0, right? The distance. So absolute value can be used to represent the distance of a number from 0 on a real number line. So, again, absolute value of -5 is 5 units. Absolute value of +5 is 5 units. Pretty hard. Pretty hard. Pretty difficult. Okay, so the formal definition, and if any of you guys take calculus, you really need to know this. The absolute value really means a if a is greater than or equal to 0, and negative a if a is less than 0. So I'm going to explain what that means, okay? So I'll give you an example with a real number. So for instance, the absolute value of -2. We know the answer is 2 because I just gave you the definition of absolute value. But if we actually use the formal definition, does everybody see that -2 would be a is less than 0? Does everybody see that? It's -2 is less than 0. So does everybody see that -2 would become -2 if I sub it into that function? So do you see why it's actually +2? So for instance, if I say, what's the absolute value of, I don't know, say +4. 4 is greater than or equal to 0. So the absolute value of 4 would be just the 4. So do you see how this works, this formal definition? So again, if it was -10, because -10 is less than 0, it would be -10, which means it's +10. Yes? You only have one sign per number, right? So, okay, I want you to find the answers to these. I'll give you a second because that's all it should take. Okay, done. So did you get 3? Did you get 7? Did you get 9? Did you get 12? Did you get 0? Oh my gosh. Okay, next one. I want you to write these from least to greatest. I'll give you a second. I'm not putting it in order right now. I'm just going to evaluate this all as decimals. What would this be? 2.4, 0.1, -0.01, 2.5. Okay, so for least would be the ones that are negative. Okay, so the least, which one would be the least? 0.0. How about -3.4? If you have a number line, if this is like positive infinity and this is negative infinity, the least is the most left, right? So if we have, say, 0, and here's -1, here's +1, say. So, next one. Yeah, -0.01. Next one. Yeah, the absolute value of -0.1. Well, you got to write it where it was, right? What it actually was. So I'm just going to cancel the ones that I've already used so that I know. Okay, where are we now? 2.4. So that would be absolute value of -12/5. Next one. Absolute value of -2 1/2. Yeah? Then absolute value 4.75, absolute, no, that's just 5, and then absolute value is 6.5. Is that what everybody got? Okay, absolute value symbols should be treated in the same manner as brackets in the order of operation. So you remember BEDMAS? You should be evaluating the absolute values first. So, here's some example 3. Let's try it. Go. Alrighty. So this is 4 subtract 6, so -2. Did you get -2 there? And then this is 5 subtract 3 times +5, so 5 minus 15, -10. Absolute value of -2, this would be -2 squared, so that would be times 4 plus 6. So this is what, -8 plus 6, -2, so then you just get 2. Yeah? Are you guys checking your answers? That's what. Okay, so this would be 4 subtract 3, so you get 1. This would be the absolute value of -4, so it's 4. Yes? This is the absolute value of -36 plus 25, so what's that? -11, so 11. Yes? I think the hardest one was B for people. I don't know why, but... It says on stock markets, individual stock and bonds fluctuate a great during the day. A great deal. Especially when the markets are volatile. A particular stock on the Toronto Stock Exchange, TSX, opened up at $13.55 per share, dropped 12.70, increased to $14.05 and closed at $13.85. Determine the total change and net change in the value of the stock for the month. The total change shows how active the stock was that month, while the net change is the difference between the starting value and the final value. So I'll give you a second to see if you can figure that out. So we're starting at $13.55 a share. So this is going to be the net change, right? Oh, the total change is what I'm doing right now. The total change. So you're starting at $13.55 and then it drops to $12.70. So how would I represent that? 9 at 12.70. Then it increased to 14.05. So what would I do? It's not increasing by $14, it's increased to that. And then it closed, so that means it dropped. Because if going from 14.05 to 13, it's dropping, right? Okay. So the reason why this is in the absolute value is because the total change would be, it doesn't matter if it's positive or negative at the end, it's going to be the absolute value of all that. So we can do this without a calculator. No? Or we can just take your old calculator and plug it in. No, probably not. But I'll give you a second. Okay, so it would be the absolute value of $1.05, which is $1.05, of course. So the total change is $1.05. The net change is saying start from the beginning of the month, so $13.55 subtract $13.85. So, how much did it change? I don't need a calculator for that. What is that? So 30 cents? Yeah? Is that all I got for you today? Square root. So, now that we know a definition of absolute value, the proper way to square root a squared actually means it's a square root of a squared is the absolute value a, which we already know is positive a if a is greater than or equal to 0, and negative a if a is less than 0. So here's how it works. If you have something like a is negative 5, yes? You see, if you square negative 5, what do you get? 25, and then if you square root 25, you get 5. So that's why the principal square root is always equal to the positive value of it. It would never equal a negative value of it. Because before in the past, you always learned that the inverse operation of square rooting is squaring, or the inverse operation of squaring is square rooting. So it should always undo it. So if you're using that logic, if you look at example 5b, then you would think that a square root undoes a square, so the answer would be negative 2. But that's not correct. The principal square root always is the positive absolute value there. The principal square root of a non-negative real number a is called the principal square root of a, written as the square root of a. So the easiest way, like, you could go 6 squared is 36, the square root of 36 is 6. But does everybody see that a square root undoes a square, so it's just 6. So where I was going with this, if you know the trick that a square root undoes a square is just the number inside. However, if it's a negative number, it's not equal to the negative number. It would be equal to the absolute value of negative 2, which is just 2. So, no, you wouldn't have to write out that. I'm just showing you a little trick. So here's the thing. There is a huge difference, and you have to know the difference between this. There's a difference between x squared equals 25 and x equals the square root of 25. And does anybody know what the difference is? I'm sorry? Yeah. So for a, you're using the function square root to solve. Here, it already is the square root. So, and when you write it as the principal square root, it automatically is the absolute value of that, which is 5. It's not plus or minus 5. Whereas over here, although we're using the function, right? We're doing this to both sides. I'm showing my steps. Does everybody see that when you, our definition right here is we're getting the absolute value of x is equal to 5. Now, what can you put into x for this? And this actually explains why it's plus or minus. So for all the people that just took my word for it's plus or minus answers, this now that you know the definition of absolute value, this is the reason why you have plus or minus. Again, the definition of a square root of x squared is the absolute value of x, and this is the square root. This is the principal square root is 5. But what does this actually mean here? You could have, yes, you could actually have positive 5 or negative 5 in there and get positive 5 out of it. So now that you have more and more math knowledge, some of the stuff that you were told or showed, it now starts to make sense why it works the way it does, right? All right.